Alright, so we'll do one more example here of solving systems of equations using the substitution method. This one's a little bit uglier, but we can use a technique to make this a lot nicer than it looks right now. Okay, a lot of people get messed up by the fractions, so if you don't like them, get rid of them. Okay, so the easiest way to get rid of the fractions, first of all, what I'm going to do is take the first equation first of all. Okay, so this is the first equation. I make this into a fraction just by putting a 1 in the denominator. So to get rid of my fraction here, what I can do is multiply the whole equation by a common denominator. So 2, 3, and 1 will all go into the number 6. So what I can do is multiply everything that's here by 6, and you'll see what happens now in a second. So it's going to be 6 times 1/2 x, 6 times 2/3 y, 6 times -1. Okay, so we can write it out like that if you prefer. Okay, so now to multiply these, just remember how to multiply fractions. So 6 I can write as 6 over 1. So if I'm doing 6 times 1/2 for now, I can write that as 6 over 1 times 1 over 2. When you multiply fractions, multiply numerator by numerator and denominator by denominator. So this will give me 6 times 1, 6, over 1 times 2, which is 2. And then 6 divided by 2 is 3. So this ugly thing here, instead of being 1/2 x now, is just going to be 3x. Okay? Take the next one, so 6 times 2/3 y. Well, 6 times 2/3 will be 6 over 1 times 2 over 3. Multiply numerator by numerator, which would be 6 times 2 over 1 times 3, which of course is 12 over 3. Which gives me 4. So this 2/3 y term will just become 4y. And of course, multiplying 6 by -1 gives me a -6. So this equation transforms from this unto something a little bit nicer to look at. So 3x plus 4y equals -6. Okay, so you notice that multiplying the equation by a common denominator got rid of all of my fractions. So I'm just going to do the same thing now for the other equation. So this equation right here. Okay, so I take y equals 1/4 x minus 5 over 3. I could write that as y over 1 first of all. So here I can see my denominators are 1, 4, and 3. I can see that 1, 4, and 3 all go into the number 12. So I can multiply the whole equation by 12. Okay, so what? I'll let you have a go at this, so just pause the video, multiply each thing here by 12, and let me know what you get. Okay, so 12 times y should be 12y. 12 times 1/4, so that will be 12 times 1, which is 12, over 1 times 4, which is 12 over 4, which of course is 3x. Okay, 12 times 5 is 60. 1 times 3 is 3, so it's 60 over 3, which should give you this equation right here. Now what I've got is this new system of equations that's much easier to look at than the other one that I had before. And you can solve this now using your substitution method just like you did before. Okay, so of course lots of ways to do this. This is just one way. So what I could do is solve equation 1 for 4y. Okay, so we did this process in the previous example, or I could solve it for 3x. It doesn't really matter. I'm going to solve it for 4y. Okay, and the reason for that is because 12y can be written as 3 times 4y. Okay, so I take that first equation. So to solve it for 4y, that means I'll have to get rid of the 3x term here. So this is a positive 3x. To get rid of that, I'd have to subtract 3x. What I do to one side of the equation, I do on the other side. So I subtract 3x on both sides. This cancels off to give me 0, leaving me with 4y equals -6 minus 3x. Okay, and now I can use the substitution into the second equation. So I take this second equation. So 12y equals 3x minus 20. I can write 12y as 3 times 4y, and then take this expression for 4y and plug it in there. Okay, so that of course gives me this here, which now we can solve because it's just one equation with one variable. 3 times negative 6 gives me a negative 18. 3 times negative 3 gives me a negative 9x. This side stays the same for now. So now I solve this equation for x. What I usually do is put my x terms on the left-hand side of the equation, my numbers or my constants on the other side. So that means this x term that's here, I'm actually going to want on the other side of the equation. So to get rid of it from this side, I would have to subtract it here. So subtracting 3x and subtracting 3x on the other side. So you can see here it cancels off, and these two terms can then go together. Okay, so negative 9x minus 3x is negative 12x, leaving the negative 18 there. Okay, and this just leaves me with just negative 20 on this side. Okay, so now to solve for x, I need to get rid of the negative 18 that's here. I could do that, of course, by adding 18 to both sides. Okay, so I add 18 to both sides. Okay, so this cancels off here. Negative 12x is equal to negative 20 plus 18, which gives me negative 2. Okay, so now to solve for x, I just need to get rid of the negative 12 here. Since this is multiplied by x, I divide by negative 12. What you do to one side, you do on the other. Divide that by negative 12. Negative divided by negative gives me a positive, and 2 over 12 reduces to 1 over 6. Now, what I'm going to do is take that answer then and substitute it back to find out what y is, right? So remember this that we found earlier. So now I'm going to take my x value, which I just found, which is 1 over 6, and plug it in for x. Okay? Just remember that this 3 is 3 over 1, right? Okay? So then, I need to solve for y. So my first step is to figure out what this multiplication here is. So that's going to be 3 times 1, which is 3, and 1 times 6, which is 6, right? Okay, so that essentially gives me 3 over 6, which reduces to 1/2. So this comes to 4y equals negative 6 minus, this comes to 1/2, okay? All right, so now I need to put these two things together. Well, this is subtraction of fractions. To subtract two fractions, you need to get a common denominator, right? And remember, this is 6 over 1. So to get my common denominator, well, 2 and 1 both go into 2. So I could make my denominator 2, which would mean I wouldn't need to change this fraction at all because my denominator is already a 2. I would need to change this one, though. So if I'm going to change this to a 2, what would I have to multiply by to give me 2? Well, I'd have to multiply 1 by 2, right? Now, what I do to my denominator, I also need to do to my numerator. So I'd have to multiply that by 2. Of course, negative 6 times 2 then gives me negative 12. Then I have the minus 1/2. Now, since I have the common denominator, I can just subtract my numerators. So I've got negative 12 minus 1, which then gives me negative 13 over 2. Okay, now I need to solve for y by getting rid of the 4 that's here. To get rid of the 4, I would have to divide both sides by 4, right? So I divide this by 4, that gives me y. And then I end up with this over here. Now this looks uglier than it actually is. It's 13 over 2 divided by 4. Okay, so if that scares you looking at a compound fraction like that, what we can do is write it like this. Okay, because this might look a bit friendlier to the eye. So negative 13 over 2 divided by 4 over 1. Well, remember, to divide fractions, you multiply by the reciprocal. So I keep this first fraction the same. I multiply by the reciprocal of 4 over 1, which is 1 over 4. And now I simply multiply negative 13 by 1, and then 2 by 4. So negative 13 times 1 gives me negative 13. 2 times 4 gives me 8. So my answer, y equals negative 13 over 8.